So in the last video, I was trying to cover the other projects in the data science repository, but this time I'm going to be covering the final capstone project. So let me go ahead and open my code editor and open my capstone project. This will usually take some time because this is not a regular Python file. It's kind of like a Python file because it uses the IPython kernel, which allows you to execute pieces of code at a time, which is very important for data science, as you cannot write long programs all at the same time and try to execute them and it doesn't work out. You need to be able to run single or smaller lines of code and then test it out. And if that works out, you move on to the next step. So this was a notebook that I created called as classification with Python. As you can see, I used the pandas library and applied the following algorithms for this dataset by accuracy evaluation methods. So this is a model used for training on this data set for predicting loan application and which would default and which would not, and predicting the probability of that. So I'm going to be running this code snippet right over here. And it says that it cannot import sklearn since I have an error with sklearn. Sklearn is a model which usually works on POSIX architecture-based systems such as Mac OS and Linux, but not on Windows. So therefore, I cannot run this, and also the other parts of the dataset. Here, as you can see, I'm getting the Lone Train CSV dataset from the web. I'm going to open my browser and show that to you now. Looks like it's not working, but yes, it's a dataset that I get from the web using the wget method, and it gets stored in the local records. As you can see here, shows 100%. But this was done on cloud, so therefore it doesn't work on my local system. Then I use pandas, the PD module, to read the CSV file. As you can see, it's a function, and you could enter the file part or buffer. And this can be a list of arguments, but here I just want to read one file. So therefore, it's just going to be this file called as lonetrain.csv. And it heads into the dataset, which means it looks into the dataset and creates a data frame object. And you can see here, it shows the unnamed dataset and the loan status, the principal amount, the terms, effective date, the due date, age, and the education level, and the male or the gender of the loan applicant. And if I want to see the shape of the dataset, it contains 346 rows and 10 columns in this matrix, which is a pretty large matrix. And I'm trying to get the due date and convert it into a date time object. As you can see, it is in this format where you have the date first and then you have the month and then the year, I think so. And then you convert it into date time object where you have this format with the dashes instead of the slashes. And the effective date is also converted into this format. And I head into the dataset. And because I head into the dataset again, it looks into the changed format and you can see the differences here. And the next thing I'm going to look at is data visualization and pre-processing. I tried to find the number of values in the loan status column to find the amount of people who have paid off their loans and the amount of people who are still in the collection, which means the people who haven't paid off their loans. And the data type of that would be int64, but that does not matter for us. This will not work on my system because I'm not using a Conda environment or Anaconda. So just to show, Anaconda is an important data science tool. It's a distribution of Python. I think the internet's slow, so that's why it's taking some time. As you can see, it says data science technology for a competitive edge. And it's a data science platform. It comes along with data science packages such as scikit-learn, NumPy, uh, SciPy, Seaborn, and many other data science packages. So this comes bundled with all of that, and this makes it the best platform for data science. This is a version of Python that's used for data science, but I do not usually use it because it causes various other problems that you won't understand. As the regular Python interpreter is very different from the Anaconda distribution of it. But for this environment, I have created an Anaconda. I've used the Anaconda interpreter, but this was done on the cloud as I said before. So therefore, I will have problems if I do this in my local system. Plus, Seaborn is just a package that works on macOS and Linux, but not on Windows. And I import Seaborn as SNS, and I have written the comments here. As you can see, it's a data visualization library like Matplotlib, but with lesser code. So what np.lenSpace does is that it's the function that returns evenly spaced values from the minimum value up into the maximum value. And it tells how much separators you need in between. So this value 10 is going to be the number of separators between the minimum value and the maximum value. And I'm using G equals SNS plus facet grid, which is just this graph right over here. And what facet grid does is that it creates an X and Y plane and a bar chart like kind of thing. And then you can customize the color. And you could say what color you want each thing to be. Like I have said here, column is going to be gender, the hue or the color is going to be loan status, and a palette, and it automatically creates the color for me. And I also told it to create a legend, as you can see here. This makes for better data analysis through a visual perspective. The second one is the same thing, but the dataset is more normalized and helps give a more statistical perspective. You can understand this kind of datasets as you go more into the data science journey and start learning more things. This is also the statistical part of it. So what this does is that it takes the weekend column of the dataset, as you can see here, and you apply a function to it. So you're saying that if the weekend values are greater than 3, you know that people who get the loan after the 3 days, which is Monday, Tuesday, and Wednesday, don't pay off the loan. So it's better to exclude the data set because that allows for better data analysis and less error less error in the model. I'm also going to reiterate this what I said just now by reading out this sentence right over here. We see that people who get the loan at the end of the week don't pay it off. So let's use feature binarization to set the threshold values less than day 4. So this was a comment that I put in this project so that people can understand why I have created this function, a lambda function, to remove value, to actually set the values to 1 if x is greater than 3, but then less than, but 0 if it's lesser than 3. Because we already know that the people who are taking the loan from day 4 up until day 6, they are not going to pay it off. But the people from day 1 to day 3, they are going to be paying it off. So 0 represents the people who pay the loan, and 1 represents the people who haven't paid off the loan. So this is what you call feature binarization, which means 0 and 1. Zeros or ones values. And now you can see it shows that weekend has been binarized. So this person has taken the day of week at 3. So the value is going to be 3. So it's going to be 0. But for this person, the third person, you can see that the day of week that he has taken the loan is 4. So we already know that people who take a loan after day 3 are not going to pay it off. So I set the value to 1, which is this function right over here. So this is called as data pre-processing, and it's a very important step in data science before analyzing the model. So I'm trying to group the data set based on gender and loan status, and I'm taking the value counts of that. This is a method in the pandas data frame, and I'm normalizing the values to find the percentages of this. As you can see, if you're trying to look at data sets that are not normalized, you wouldn't be able to interpret the meaning. It may be something like 267 values or 328 values. But these are just numerical values that you need to divide by the total number of values in order to understand the statistical significance. But here, the value counts method with the normalized equals true parameter will help you find the percentages of each kinds of category in the data set. So a person who is female and has paid off the loan would be 86%, and a person who hasn't paid off and female would be 0.34 or 13.5% of the females haven't paid off. And for the male, similarly, you can see 73% and 26.8%. You can see here, these comments also tell you same thing. Df gender dot replace, and you're giving the parameter to replace equals male female, value equals 0 1, and in place equals true. This is again the feature binarization thing that I've shown above. But here I'm not using a lambda function because in this case I want to look at the data sets and I'm going to replace it and not just change the values. And I'm heading into the data set, and now you can see that the gender that's being shown here, male or female, have been converted to a binary value, which means that the data set has been converted into from categorical data into numerical data, which allows for data analysis. It's very hard to conduct data analysis on categorical data, and there are separate techniques for that, but those aren't usually effective. So you actually binarize the data, convert them into numbers. So you know that 0 is female and 1 is male or something like that. Again, you group the data set and you take the value counts, but this time you look at the education instead of the gender of the loan applicants. And here you can see that, I mean, the spelling is wrong. It's bachelor, but yeah, it shows the education. Bachelor's degree, high school or below, master's or above, and college. And they have paid the loan with such percentages. Now you can see that the percentages and really get to start to interpret the data. Now we are going to feed it into the model. You're trying to select the required terms and then remove the other terms. This is what I reiterated before, but I'm reiterating now because I'm trying to say that it's better to always convert categorical variables to binary variables and append them to the data frame, because you're only going to be able to interpret these columns of the data set. Although you have such a big data set, the amount of data which you can actually use and interpret is going to be so little. I'm concatenating the data set and I'm dropping the masters or above data set because those contain categorical variables. And I'm heading into the data set. As you can see, all of the values now are numerical. Now just try to look back and compare this to the previous values. What do you see here? You see a lot of categorical values. High school or below, that's a categorical. Male, that's a categorical. Paid off, that's going to be categorical. But here, the paid off male, female, or the education status have been either converted or to binary format, or drop from the dataset, as you can see here. Everything is converted to zeros and ones, or in general, numerical values. So I created a feature dataset, then I created a Y dataset, and then I set the standard scaler, which is nothing but normalizing the dataset, or standardization in other terms, normalization. After normalization, this will be my data, which is nothing but multiple averages that you won't understand. And this is the NumPy array it has created right here. So I've used multiple models to find the same results. This was my first model which I used, which is k nearest neighbor. I found the optimal value for this data set to be k equals 1. And the second one I have used is decision trees, which helped me make a decision tree based on the entropy of the nodes. To understand these in depth, you are supposed to take the data science course or try to understand the mathematics behind it. So therefore, you'll be able to understand these models. And support vector machine and logistic regression, which is the same regression I used in my last video right over here. That's sigmoid. Sigmoid function is example of a logistic function. So that's what I'm trying to do here. Except here I'm trying to find the probability of a loan default or a loan being paid off. And I'm trying to evaluate the model that I've created over here. See, as you can see here, it's an LLR model. So it's already a logistic model being created. So I'm just trying to evaluate this model here by using multiple values and printing the accuracy scores. As you can see, my model has a 75% accuracy, and you can see I compared the paid off or the actual to the predicted values for each model. And to compare this model, I would say that my decision tree and the SVM classifiers are the best models for this situation. While the KNN algorithm and log loss may be faster, but they are not the best models in this situation. So that's all I wanted to cover. Hope you have a good day and thank you.